Dropping a database column on a high-traffic table is a common cause of production outages. The operation requires an access-exclusive lock that prevents any other transaction from accessing the table. While the metadata update takes only milliseconds, the command must wait for all existing queries to finish. During this wait, every new incoming query is blocked in a first-in, first-out queue. This queue quickly saturates the application connection pool. Once the pool is full, the entire application stops responding to users, even though the database might otherwise be healthy. To avoid this, you must first remove all references to the column from your application code. This includes every structured query language statement and any object relational mapping configurations. Searching for explicit column names is insufficient. You must also identify and replace every select star query, because these will fail once the column is no longer present in the result set. Object relational mappers like ActiveRecord or Hibernate often cache table schemas. You must explicitly configure these frameworks to ignore the target column before you attempt any database changes.
Deploy the code changes and verify that no active application instance is still requesting the column. Monitor your database logs for any remaining missing column errors during the transition phase. Before executing the drop command, check for database dependencies. Views, functions, and triggers that reference the column will prevent the drop from succeeding and must be updated first. Query the information schema view column usage table to find every view dependent on the column. You must drop these views and recreate them without the column in a single transaction. Check for foreign key constraints that link to the column. Use the alter table command to drop these constraints before proceeding with the column removal to avoid dependency errors. Instead of a direct drop, consider marking the column as unused. The setUnused syntax is a fast metadata operation that makes the column invisible to all subsequent queries immediately. Marking a column as unused is functionally equivalent to dropping it for the application. It allows you to confirm that the system remains stable before physically deleting the data from the disk. To safely execute the drop, set a lock timeout for your session. This prevents the migration from waiting indefinitely and blocking the rest of your production traffic. Set the lock timeout to a short duration, like 500 milliseconds. If the command cannot acquire the lock within this window, it will fail harmlessly without causing a bottleneck. Wrap your migration in a retry loop. If the lock acquisition fails due to high traffic, the script should wait and attempt the operation again during a lower traffic period. Identify blocking processes by querying the pg_stat_activity table. Look for long-running transactions or idle in-transaction sessions that are holding locks on your target table. Long-running analytics queries are the most common blockers for schema changes. You may need to terminate these specific backend process identifiers to allow your migration to proceed. When Postgres drops a column, it does not immediately reclaim the physical disk space. It simply marks the attribute as dropped in the internal system catalog and hides it from users.
The data remains on disk until the affected rows are updated or the table is rewritten. This means a column drop does not provide an immediate reduction in database storage size. To physically reclaim the space, you must eventually run a vacuum full or use a tool like pgrepack. These operations rewrite the entire table without the dropped column data. Vacuum full requires an access-exclusive lock for the entire duration of the rewrite. This is often unacceptable for large production tables due to the extended downtime required. The pgrepack extension offers a zero-downtime alternative for space reclamation. It creates a new table, copies the data, and swaps the tables using triggers to capture concurrent changes. If you use logical replication, be aware that schema changes are not automatically propagated to subscribers. You must coordinate the column drop across your entire infrastructure to prevent replication breaks. Physical streaming replicas will experience a recovery conflict if they are running long queries when the drop command arrives. This can lead to increased replication lag and standby disconnection.
Adjust the max standby streaming delay parameter to manage how long replicas wait before killing local queries that conflict with the incoming schema change from the primary server. Indexes on the column you are dropping should be removed separately using the drop index concurrently command. This prevents long locking periods during the index deletion phase. The concurrently keyword allows Postgres to drop the index without taking an exclusive lock on the table. This is an essential step for maintaining availability during cleanup. Check for any check constraints or partitions that rely on the column. Partitioned tables require you to drop the column from the parent table, which cascades to all children. In a partitioned setup, the lock must be acquired on every single partition. This increases the chance of a lock conflict and requires a more conservative migration strategy. Verify that no background workers or cron jobs are using the column. These isolated processes are frequently overlooked and can cause intermittent errors after the column is removed. Examine your log files for errors related to prepared statements. Some drivers cache statements and may need to be restarted or cleared to recognize the new table schema.
If the column is part of a multi-column index, the entire index must be dropped and recreated without that column. Plan this recreation during off-peak hours to minimize load. Use the Create Index Concurrently command to build the new replacement index. This ensures that your database remains performant while you restructure your indexing strategy. Postgres handles column drops by incrementing the table version. Every active session must eventually refresh its local metadata cache to align with the latest state of the system catalogs. Avoid dropping multiple columns in separate alter table statements. Combine them into a single command to minimize the number of times you must acquire the access exclusive lock. A single alter table statement with multiple drop actions is atomic. It either succeeds entirely or fails entirely, ensuring your schema remains in a consistent and predictable state. If you must perform the drop on a table with billions of rows, monitor the impact on auto-vacuum. Schema changes can reset statistics and trigger intensive auto-vacuum worker activity. Analyze the table immediately after the drop to update the query planner statistics. This prevents the database from making poor execution plan choices based on outdated column information. Always test your migration script in a staging environment that mirrors your production load. This is the only way to accurately predict lock contention and timing issues. Simulate high concurrent traffic during your staging tests. Tools like pgbench can help recreate the conditions where a column drop might fail due to lock timeouts or deadlocks. Dropping a column is an irreversible operation in terms of data recovery. Once the transaction commits, the data is no longer accessible via standard structured query language commands. Before proceeding, ensure you have a fresh physical backup or a logical dump of the column data. This provides a safety net if the column is needed later for auditing. Integrated your migration steps into your continuous integration and continuous deployment pipeline. Automating the lock timeout and retry logic removes the risk of human error during manual execution. Standardize your schema change procedures across the engineering team. Consistent patterns for dropping columns reduce the likelihood of accidental downtime during routine maintenance tasks monitored. Modern Postgres versions have optimized metadata operations, making the lock duration very short. By managing the lock queue effectively, you can achieve true zero-downtime schema evolution.